Algebra 1 students, welcome to today's notes 6.6. We're looking at graphing systems of linear inequalities. We've already looked at how we graph inequalities just with one line, but now we're basically going to combine two into one graph and see what that looks like. So, we'll start with the definition. A system of linear inequalities is made up of two or more linear inequalities, and we'll stick to two in this course for now. A solution of a system of linear inequalities is an ordered pair that makes all the inequalities true. There are often lots of those, and so the graph would be the set of all the points that represent the solutions. So let's take a look at what that means. And I think some of the words may be a little much to absorb, but I think you can handle it once you see what we're talking about. So let's start by graphing y is greater than or equal to 3x minus 3. So what I'm going to do is start by just finding the slope we know is 3, and we know the y-intercept is negative 3. I've already graphed that y-intercept. Now we're going to apply the slope, up 3, right 1, and you could do that if you prefer, down 3 and left 1. This is nothing new to you, you're seasoned veterans, and you'll notice that it's greater than or equal to, so I actually want to use the solid line to sketch it. It looks like this. And then we look at where we would shade. Now this is something that's different when we deal with a system rather than just a single inequality. With the system, I'm not going to shade just yet, but I do know if I were shading y is greater than 3x minus 3, the graph would be shaded above. I like to just go on there and put arrows to kind of show where that would be headed. Again, you'll notice I haven't graphed this just yet. I haven't shaded it, I should say. I'm leaving it just as kind of a reminder of this is where I'm going to head. So let's take a look at the second line. I'm going to do a little color coding here. We'll use green this time. This time my slope is negative 2. The y-intercept is 4. So I'm going to go mark those two things down. There's my y-intercept of 4. Slope is negative 2, so I'm going down 2 and right 1. And the graph looks something like this. And again, we need to connect. Do remember in this case that it's actually a dashed line. And again, slope negative 2 would look something like this. I know my line's not dashed. I'll change it in just a moment. And this is the magic of using technology. I can go in and just say, let's change that line to a dashed line. It's a lovely thing. All right, that'll work. Now the other part of this, it says y is greater than negative 2x plus 4. So again, I'm shading above just like we did on the previous. Now the last step to these is to actually go ahead and shade in the region where both things are true, which of course is up here. Now it looks like a triangle on our graph, but the reality is, as you can imagine, this is going to extend infinitely upward, so to call it a triangle isn't exactly true, but it looks like one for our purposes on this graph. So there it is. Any point within that shaded region would satisfy the system of inequalities. All right, let's take a look at the next one. This time we are in a different form. We're looking at standard form. So I'm going to actually graph this. This one works out pretty nicely. I'm going to graph by using intercepts. So in this case, I know if x is 0, then y would have to be 6. And if y is 0, then x has to be negative 3. That gives me 2 points. And I need to draw the line that connects them. Again, this is a dashed line because of the fact that it's greater than, it's not greater than or equal to. Now we have to be a little careful when we're in standard form about which side we actually shade, because by appearances you'd say, well, it's greater than, we shade above. But watch this. Let's test a point. test 0, 0. Okay, 0 minus 0 greater than -6. That's true. 0, 0 is part of the solution. So in this scenario, we're actually shading below. Now what changes that from being above to below is the fact that we have a negative y. You can learn that rule, or you can just simply know, hey, anytime it's standard form, we got to test a point. Let's test it. All right, let's do the same thing on the next one. If x is 0, y would be 3. And if y is 0, then x would be 4. So 0, 3 and 4, 0. This is greater than equal to, so we're actually going to use a solid line this time. Should look something like this. And really, when it comes down to it, we're just trying to get a really good sketch. It may not be perfect if we extend it a really long way, but I think we're getting the idea what this graph would look like. And then again, we want to test a point. Let's test 0, 0. 0 plus 4 times 0, which is 0, greater than or equal to 12? No. So we know 0, 0 is not part of the solution here, which means we have to be shading above this line. And again, our job is to take a look at this and say, well, where are both of these things true? Where is the shading going to overlap? And it's this region out here. You can take a long time to shade and get this perfect. That's probably not how you want to spend hours of your day, but once you get started, it's just so hard to stop. I mean, how fun is this? It's like coloring and trying to stay in the lines. All right, good stuff. All right, let's take a look at another one. This time we're in kind of a mixed form. The number 3, the first equation we have is given to us in point slope form. Now some of you might like to distribute that 1/2 and then change it to slope intercept. I would be fine with that, but I'm kind of an advanced math thinker, and so can you. You can get there, but what I would look at is if it's x plus 6, we know that the x value for our point and the point slope had to be -6. Y minus 5 means the y value had to be +5. So that tells me right there that I'm going through the point -6, 5. The other thing I know is that my slope is 1/2. So I'm going up 1, right 2. Up 1, right 2. And you could continue that as far as you think you need to go. And that's as far as I think I need to go. And then connect. And again, it's a solid line because we're talking about less than or equal to. Now again, it's probably wise to test a point, although it's a little bit weird on this. When you plug in all these values, it could be a little confusing. So I might actually just look at this one and say, well, if I added 5 to both sides, I would have y is less than or equal to. I could say with 100% confidence that we are shading below. So with point slope, you can actually trust the less than. Okay, and then actually, why don't you do this? Pause the video, do the second half of this graph on your own, and then see what your solution looks like. Compare it to mine. All right, welcome back. Here is what the solution should look like, something like this. You can see the second line had a slope of -3, a y-intercept of 5, and it was a greater than or equal to situation, so I went ahead and shaded above. The first line was shaded below. The intersection of those two shaded regions was this area over here to the right. All right, we have one more, and on this one we're actually going to work backwards from what we've done in the previous problems. And what I want to do is just look at this as two separate inequalities and solve them kind of on their own merits, and then we'll put it all together for a system. So let's take a look at this blue line, and let's think about the things we know. Like, I'm noticing that it's solid, I'm noticing it's shaded above. Those things we'll come back to in a minute. But here's something I notice. The y-intercept, I'll write it over here so it'll be a little more visible, is 1. Another thing I notice is that the slope, if I go from this point over to here, I'm going down 1 and right 3. So I know my slope is -1/3. I can write my equation from that information. The fact that we're shaded above and that this line is solid tells me its y is greater than or equal to, and then I'd have negative 1/3 x plus 1. That's the linear equation we came up with. All right, we're going to go through the same process with this red portion of the graph. You can see that it's dashed and that it's shaded below. That tells me it's going to be a less than situation. The other things I notice up here, I've got a y-intercept that's equal to 3. And then we need to find another good point. It looks like right here is a good point where I'm going down 2 and left 1. That would give me a slope of negative 2. So that equation would be y is less than negative 2x plus 3. Folks, that's your system. I hope these notes make sense to you. It's really just taking something that we already have been practicing and adding another dimension to it, 2 inequality graphs instead of just 1. I think if you've learned the first part of it well, this shouldn't be too huge of a step, and you guys come to class ready to work, and we'll have a great day.